SOL 6.13 was about quadrilaterals. And if you remember, quadrilaterals have 4 sides. So I'm just going to, up here beside quadrilateral, somewhere I'm going to put that they are 4 sides. Now I did realize as we started doing practice problems, a lot of you did not remember what a polygon was. So basically, this top box I want to put polygon. And all a polygon is any closed figure. So a quadrilateral is a polygon. A polygon is your triangles, triangles, quadrilaterals, pentagons, hexagons, heptagons, any figure that is closed. So I'm just going to put that, any closed figure. It's not a circle, but it has to have straight lines, but it's a quadrilateral, I just want to point out, is a polygon because it's a closed shape. So underneath polygon right here, we're going to put a quadrilateral. Let me spell that. And we've already kind of talked about that. A quadrilateral is any closed shape. It's 4 sides. So if you remember then, we got a little bit more specific after we started talking about quadrilaterals. We started naming things based on how many pairs of parallel sides. Now I know this flowchart looks a little different than the one we've done, but that's only because I put the thing over on the side that has the ones underneath it instead of in the middle. And it still means the same thing though. So let's talk about what is a shape called that has 0 pairs of parallel sides. The shape that has 0 pairs of parallel sides, hopefully it came to mind, is a kite. So a kite, remember, has 0 pairs of parallel sides. So I'm literally going to write that underneath here. 0 pairs of parallel sides. But it does have what we call adjacent congruence. So I'm going to draw like a picture of this here. Remember the top 2 sides, they're adjacent because they're next to each other, and they're congruent, so we can put a little tick mark on each one. And then the 2 bottom ones are a little bit longer, but they're also congruent to each other. So we put those the 2 hatch marks to show that they are congruent to one another. So a kite has 0 pairs of parallel sides. Now hopefully you're thinking now, our next one, if we go up, has 1 pair of parallel sides. What would that be? And hopefully your mind's already going to that would be a trapezoid. Has 1 pair of parallel sides. I know you're thinking, Miss Howard, we've already done these notes, but this chart is something you should be able to duplicate on your scratch paper on the SOL. Something that looks similar to this. Yours might be in a different area, but it should be quadrilateral at top, and then the different categorizations underneath it. So a trapezoid. A basic trapezoid is the one that most people draw, that looks like this. Plain old trapezoid. 1 pair of parallel sides. We show that they're parallel using this little arrow symbol. But we also need to recognize that a trapezoid can also look like this right here and have a right angle or 2 right angles, because these 2 lines right here are parallel. So those can also be parallel. So trapezoids have 1 pair of parallel sides. Kites have 0 pairs. And then we come to our next one, our parallelogram. And a parallelogram, if you remember, has 2 pairs of parallel sides. 2 pairs of parallel sides. And this is the one that the basic parallelogram. It's got your longer sides and they're slanted. And to show that they're parallel, the top two, top and bottom, we put one arrow on. And to show that these two are parallel to each other, we put two arrows. So a parallelogram, two pairs of parallel sides. Now parallelograms was the one that we said could keep going because you can get a little bit more specific. If you took this parallelogram and you kept it basically the same length sides but straightened it up and gave it 4 right angles, it would be called a rectangle. So a rectangle, I'm just going to put, has 4 right angles. It has to. If it doesn't have 4 right angles, it cannot be a rectangle. And I'll draw it, even though I'm pretty sure you guys know what a rectangle looks like. Remember, we put in the corner, we put our little boxes to represent rectangles, right angles. Now what if we took our parallelogram and we kept it slanted but made them all 4 sides congruent? And if you remember that, that would be called a rhombus. I'm going to put 4 congruent sides. So it still stays slanted. And do our best to make sure all 4 are the same. But even if you're like me and it's not perfect, when I put these little hatch marks on it, the 4 lines, it tells me that they should all be the same. Even if it's not perfect drawing, they should all be the same. And then remember, if we took our parallelogram and put it together with our rectangle and our rhombus, we end up at the bottom with a square. And the square has everything above it. It has 4 right angles, like a rectangle. It has 4 congruent sides, like a rhombus. It has the top and bottom are parallel, the other 2 are parallel, and it also has 4 sides like a quadrilateral. So it has all parts of that flow chart. And that's going to lead me into the 2 other parts we have to know for quadrilaterals. The first one is using this flow chart, and that is our always, if you remember, I'm going to write up here, always, sometimes, and never rules. So always, sometimes, and never. If you'll go ahead and write that down. And remember we said this chart, that's why I want you to be able to produce it on the SOL so this can help you. Because always means if I go up my chart, I'm going to put an arrow here to show that up. If I go up my chart, it's an always. A square is always a rhombus. A rhombus is always a parallelogram. A parallelogram is always a quadrilateral. A kite is always a quadrilateral. A trapezoid is always a quadrilateral. Sometimes is when you go down your chart. Parallelograms are sometimes rectangles, sometimes they're rhombuses, sometimes they're squares. Quadrilaterals are sometimes kites, sometimes trapezoids. And then never is when we go left to right. Kites will never be trapezoids. Trapezoids will never be kites. Trapezoids will never be parallelograms. Rectangles and rhombuses will never match up with each other. And one last thing, just to write on here, 360 degrees. Remember that an inside part, the angles always equal 360 degrees. So angles always add up to 360 degrees. Never fails. Doesn't matter which one of these quadrilaterals they are, it'll always be 360 degrees. At this point, you may go ahead and do your practice problems on the back.